So our keynote speaker tonight is the founding principal of Building Science Corporation, buildingscience.com, and Lstiburek Consulting Incorporated. His work ranges widely from providing expert witness testimony to overseeing development projects to writing for ASHRAE. He is an ASHRAE fellow. Is that correct? Okay. No. Writing for the ASHRAE Journal and buildingscience.com. His commitment to advancing the building industry has had a lasting impact on building codes and practices throughout the world, particularly in the areas of air barriers, vapor barriers, and vented and unvented roof assemblies. Our speaker is also an acclaimed educator who has taught thousands of professionals, me as one, over the past 3 decades, and written countless papers as well as the best-selling builder guides. And fittingly, the Wall Street Journal has described him as the Dean of North America Building Science. He holds a Bachelor of Applied Science in Mechanical Engineering, a Master's of Engineering and Civil Engineering, and a Doctor of Philosophy in Building Science. So with his business partner, Betsy Pettit, he founded Building Science Corporation in 1990 and has been a key figure in establishing Building Science Corporation as one of the most influential, innovative, and respected building science firms in all of North America. With me, giving Dr. Joe Lstiburek a hand.
Thank you. Well, it's a tremendous honor to be invited to civilization. I'm coming to you from Boston. Yeah, I didn't grow up in Boston, so I'm polite and I know how to drive. It's a big difference. Well, let's get started, and I'm sure that I'm going to get into some level of trouble. This is sort of obvious. Buildings that last a long time, that are energy efficient, just by definition, are green and carbon sequestering. They are durable, sustainable, and resilient. So just ponder this. You want something to last a long time. Whoa. Why do we need a computer model? You ponder that. Long time means a seriously long time, and energy efficient means seriously energy efficient. Duh. This is if you're an MIT graduate, I needed to explain it to you a little bit better. Making existing buildings last a time and more durable and energy efficient is very carbon sequestering and green. So if you take a building that's already been built and you turn it into something that lasts a very long time, that's ultra energy efficient, wow. Of course, what I'm going to tell you is that we're doing it so wrong that we're actually destroying our existing old buildings because we're doing it incorrectly, and you're better off not doing anything at all instead of doing something that's stupid. I'm already in trouble. Okay, that was a double duh. Yeah, there's more. Wood is good, it grows on trees. Repeat after me. Wood is good, it grows on trees. I know, I'm a legend. Triple duh. Yeah, there's more. New buildings are easy, existing buildings are hard. All these people that are saying we want to be, net zero by 3035, or whatever must be, Harvard or MIT grads because they have no freaking idea. The new stuff is easy compared to doing the old stuff. And you want to do the old stuff in such a way that you don't destroy the historic character of the old stuff. Yeah. And so can we take existing buildings and not screw it up? The answer is yeah, but we're not doing it the right way right now. And I'll get into that. Historic buildings, really, really, really not easy. Because best way to do things is to insulate the buildings on the outside. You know, I grew up in Canada, and when it got cold, we would pull the sweater over the outside of us. We wouldn't eat it and shove it into our ribs. So you want to be a sweater wearer, not a sweater eater. So most of the wood frame buildings are people that eat their sweaters as opposed to ones that should wear the sweater, you know, duh. So continuous insulation on the outside of a new building is very easy. If you put continuous insulation on the outside of a historic building, I will hunt you down and talk sternly to you because you change the entire character. But if you do it on the inside, it's even more dangerous. And I'm going to tease you a little bit and get into that in a minute. So don't do stupid things. I'm going to spend a bit of time defining stupid. Don't kill people. Don't make them sick. Don't kill the building. Don't make the building sick. I don't understand how this is so complicated that people argue about this. Don't kill people. Way back when, in early 70s, late 70s, when I was first doing stuff, I said, look, it's okay for buildings to get wet if they dry. Wetting followed by drying is okay. Everybody with me on this? It's okay to get wet if it dries. I also pointed out that drying requires an exchange of energy. So what did we do with the exchange of energy? We dramatically reduced it. So when buildings get wet today, they don't dry. Now what happened was I predicted that this was going to happen. I was a young punk kid at the time, but I couldn't get any work because I got blacklisted because I was anti-energy efficient. They started rotting. And then, well, we have to keep the moisture from getting into the walls and roofs. And so they began to caulk and seal and make the building airtight. And what happened was, as I said, that's going to mess up the ability of the chimneys. The gas and oil furnaces are not going to work, and you're going to kill people. Well, guess what? We started killing people. I testified at a coroner's inquest in Mississauga, Ontario in 1982 that the reason that, you know, they died is because they involved a government program to air seal the building. I was told if I was going to testify, I would lose my job. So I looked at my iron ring. I'll tell you the story about that in a minute. And I got blacklisted and couldn't get any work in Canada, so that's why I became an American. You all accept everybody. Engineers from Canada, you can tell them they all have an iron ring that they wear in the little finger of their working hand. The iron comes from a bridge that collapsed in the St. Lawrence River in 1911. 80 people died. They hauled the wreckage out of the river, and they failed because of an engineering error. The most famous engineer at the time, his name was Haultain. He was a good friend of Rudyard Kipling. So he wrote the Kipling Ritual. So every engineer that graduates in Canada gets an iron ring in the Kipling Ritual to remind them of their moral and ethical responsibility to society. So here I am. They now want me back in Canada, but it's freaking cold up there, Jesus. Okay, definition of a building. This is my definition of a building that I stole from dead people a long time ago. A building is an environmental separator. Its function is to keep the outside out and the inside in. Well, why? Well, sometimes the outside sucks and you don't want it inside. And sometimes the inside sucks and you don't want the inside in the thing that separates the inside from the outside. Anybody not get that? Are there any architects here? I can do it again. Well, what are the odds that that environmental separator is going to be constructed perfectly? Slim to none, and slim as just left town. So you have to make sure that if it gets wet from the inside, you kick that moisture back or you let it through. If it gets in from the outside, you have to decide to kick it back or let it through. And how much you kick back and let through in each direction depends on a whole bunch of stuff that we define in Canada and the United States as building science. In Europe, they define it as building physics. We're more correct in Canada and the United States because physics is very narrow, science is much broader. That's why you don't want to listen to anybody from Germany. This is meant to mess up the Passive House folks, okay? Come on. Geez, I think I told you they don't let me teach undergraduates anymore because the snowflakes don't have a sense of humor. So this is the definition of environmental separation. This isn't my definition. This was figured out before I was born. This is done actually when the Toronto Maple Leafs were actually winning hockey games. They're a semi-professional hockey team that hasn't won since 1967. I was 12 years old. I watched that game. I have a T-shirt that says, "Once more before I die, please." All right, so this is the list. It came from Neil Hutchin and Gus Handegord, and I had they're mentors of mine. They both have passed a long time ago, but I was young Joseph. And they said, "Young Joseph, not all of these things are equally important. The ones that kill people are more important than the ones that piss off people." Anybody not? Okay. So, first order, fire, followed by structure, followed by wind, followed by flood, followed by contaminants. The second order are materials and energy. Our codes evolved based on fire first. You know, the city of London burned, then Chicago burned in 1867, which was the last time the Leafs, I think, won. The very next year, Boston burned, but nobody remembers the Boston fire because back then, Boston always finished second. So we, in the United States, build out of stuff that burns, but not a lot of people die because we're very good at it. We just happen to be forgetting why we were so good. And so now thousands of buildings burned in California. And so we have to build a wall between California and the rest of the country so those ideas don't get across the Mississippi. I warned them about this. Most of the fires, most of the houses burned because their attics are vented. Vented attics have the embers come in. And then we're over-venting our walls. So you don't want to vent your wall and you don't want to vent your attic. Oh my God, they're going to rot. No, they're not. You have to build them differently. Well, we have to ventilate our wall. No, you're an idiot. And by the way, it's really dangerous. We'll get into that. The trouble is that the energy folks, they don't understand physics. They're activists. So if you can't do math or physics, you're an activist. And they're very, very successful. And so we're changing the energy flow, and we're screwing up the other stuff that's working just fine. Now, I'm not anti-energy. I can't help it. I'm an engineer. Engineers are born with genetic defects. It's the efficiency gene. We can't help ourselves. But I'm an old engineer, and I know not to do stupid stuff. So it's important that you don't kill people and make them sick because you've saved energy. You want to make the building last a long time. You want the people to last even longer, and you still want to save energy. We're not doing it correctly. Well, Joe, you're just a denier. No, you're an idiot. All right. There are three principal damage functions, and we call them damage functions because they cause damage. I'm just laying this out. The worst of the worst of the worst is water, followed by heat, followed by UV. They're listed in an order of importance. This is after we've handled fire and structure. After we've handled fire and structure. And we shouldn't focus on these in such a way that we screw up fire and structure. Fire first, structure second, energy last. What's driving the boat now? Energy. And it's screwing up the fire and the structure. I want the energy to be there. I just don't want to hurt the fire and the structure. Grenfell Tower, United Kingdom, June 2017. 80 people died. Now, what the press didn't tell you was that this was a retrofit of an uninsulated masonry building, and that the fire started on the second floor because they changed the heating and cooling systems to use refrigerants that were greeny-weeny but were flammable. So we have a flammable refrigerant because the greeny-weenies said we want to have greeny-weenyism. That started a fire that got super insulated on the outside to save energy. And, you know, this is embarrassing, disgusting, and stupid. And we want to make sure that none of those people cross the ocean with the pilgrims and the boats to bring that information to the United States. I'm kind of making the stories up a little bit here. This is what it started as. It's 35, 40 years old, no insulation. It was beautiful. Then they insulated up the yin-yang wazoo on the outside. The real problem was the airspace, the ventilated cladding. That ventilated cladding allowed the fire to go up all the way. Well, we need to ventilate the claddings. No, you don't. Well, we have to have ventilated cladding. Says who? Well, we read it in, we did a woofing analysis. You're an idiot. Okay, I'm going to start talking about effective compartmentalization, egress, and whatever. So this is what the old building was. There was nothing there to burn because it was all out of concrete and rocks. Rocks don't burn. Repeat after me. Rocks don't burn. So let's insulate it on the outside with compressed napalm insulation. And then ventilate it with a 2-inch airspace, because man, you want to ventilate the shit out of, you want to ventilate the heck out of your cladding because it's more energy efficient. No, you're an idiot. So the fire starts on the second floor because of the flammable refrigerant, which they're not telling you about. You know, you shouldn't have air conditioning systems that have stuff in them that burns. Well, it's green. You're an idiot. And it goes up the cladding space, the 2-inch space. There are people that want 4-inch spaces because it saves energy. You're an idiot. If the airspace is a 1/2 inch or less, you don't have to fire stop it because of the boundary layer friction of the two surfaces starves the fire. We learned about this in the 60s. This is a time of Paul McCartney's band Before Wings. Elvis Presley, not Elvis Costello. And so we burned walls and we figured it out. So this idea of a 2-inch and a 4-inch ventilated cladding to save energy is dangerous, and you shouldn't do it. Stop. Up, and then it in. Okay, it wasn't the first one. A dozen other buildings are already burned, but we weren't, we weren't paying attention because clearly the United Arab Emirates are not, they're not sophisticated. Yeah, whoa, yeah. Of course, the French are even less sophisticated, right? There's going to be a name of one coming up that you're not going to believe was the actual name. The Dubai Torch Tower. If the airspace had been less than 1/2 inch, this wouldn't have happened. And now for something completely different. Marco Polo Apartments, Honolulu, Hawaii, July 2017. How many people remember the name EIFS, External Insulation Finish Systems? Like drive it and stow. You've got expanded polystyrene, EPS, with a very thin lamina, right? Well, it should burn. No, it doesn't, because there isn't an air gap. So when they had a fire, the fire was basically constrained to just the unit or two. You don't lose the building, you just lose a little part. This is like really important, okay? Yay, woo. Trump Tower. I'm sure you're going to blame the fires on Trump. It popped out, but it was very limited because it wasn't a ventilated space. Didn't have a big space. Stop it with the big freaking spaces. Jeez. Monte Carlo Casino. The thing that burned the most was the sign, which is mostly EIFS. So where did all this stupidity start? Hooker Chemical Company building, Niagara Falls, New York. They built it on top of Love Canal, but that was another issue. It was the first double wall. They had an 8-inch space between the inner layers of glass and the outer layers of glass. And the idea was they wanted to ventilate, and they were going to save so much energy because of the ventilation of the ventilated cladding. And I got into trouble way back then because I argued with them. That was the first time I got yelled at by ASHRAE. I wrote a letter because ASHRAE gave them an award, and I said, in order for that to save any energy, they'd have to have subsonic flow between those two surfaces. And that would suck small animals and children off the sidewalk and inject them into low Earth orbit. Are you freaking kidding me? Colossally, batshit crazy, stupid. And we're encouraging it. I'm going to hunt you all down and talk sternly to you. Don't do this. Of course, if you are famous and you run a shoe company that's got a nice logo and you're a billionaire, they built this famous double wall. It got all kinds of awards. And I had some fun with them. I said, well, have you actually measured the energy consumption? If you don't measure it, you're full of shit, speaking technically. I don't believe it unless you measure it. We did a simulation. I can get any answer you want with a simulation. Measure it. You don't measure it, I don't believe you. I mean, look at this. Wow, it's beautiful, only for idiots. I said, what you should do is that's where the homeless should be put up. Okay, that didn't get a laugh. It was probably not correct. So where did this stupidity come from? Yeah. They should stick to building Porsches. I mean, look at this. Oh, we got fans in there. Woo! Why don't you just have more efficient glass? You could have triple pane or quad pane with, Krypton filled, made by Lex Luthor Industries. Could have an R10 window that doesn't burn. Woo! I mean, look at this shit. We need to build some kind of a trade barrier so this doesn't cross the Atlantic. Now, we became very good at figuring this out in the United States, NFPA 285. You actually build the wall and you burn it. If you don't burn it, I don't believe you. We did a calculation. I don't care. Burn it. Burn it. We figured it out by burning things. Pass, fail. Jesse Beidel was the legend. He's still alive. You ever see him, shake his hand, hug him. I would hang out with him at code hearings, and he kind of adopted me. Wicked sense of humor, new stuff. Young Joseph, make sure you burn it. If you don't burn it, I don't believe you. Okay, Jesse, okay. Wildfires. Biggest problem, embers drawn into vented attics. Don't vent the attic. Anybody not get this? Well, you have to vent the attic. Why? To save energy? No, you don't. To keep it from rotting? No, you don't need to vent it to keep it from rotting. Why do you vent the attic? You don't know, do you? Well, it's going to make the shingles and the membrane cooler, and it will last longer. Well, don't use a black roof, use a white roof. Well, you're going to avoid the shingle warranty. Okay, let me help you with this. 3 identical roofs, one in Houston, one in St. Louis, and one in Minneapolis. Same size building, same insulation. Which roof is going to be the coldest? Minneapolis, come on, I'm not tricking you. Which is going to be the hottest? How come they have the same shingle warranty? Black roof runs at 180 degrees, white roof runs at 120 degrees. How come the black roof and the white roof have the same warranty? The roof that faces southwest is hotter than the roof that faces northeast, but they have the same warranty. Duh. Is there a reason to vent? Yeah. Ice damming for snow protection. It's the only place. So I always put a vented over roof over an unvented under roof, and in a place where it burns and there's also snow, I make the vents closable. Governments are incompetent. Activists are even more incompetent. Forest management, good luck with that. Water supply, even more good luck with that. Okay, I don't want to be too depressing here. I'm going to give you some good news. One of my heroes was Winston Churchill, and he described America and Americans this way. He said, Americans can always be counted upon to do the right thing after all of the alternatives have been exhausted. And we're working our way through exhausting the stupid alternatives. We insulated up the yin-yang wazoo and our rotting buildings. We're making them airtight, and what's happening is we're having indoor air quality problems. And so what did we do? We exported that technology to Great Britain, and the roofs are rotting like crazy. In fact, you can't get a mortgage if you insulate your attic in Great Britain. And, they're repeating all of the stupid stuff we did in Canada in the 80s, which we exported to the United States to get even for the Wayne Gretzky trade. You got Canada's best hockey player, we're going to rot your houses. So we then shipped that across to Great Britain, and now we've shipped it across to Australia and New Zealand. Woo. They're having the problems that we created, that we fixed. The Department of Energy weatherization program is magnificent. We have, we actually test for spillage and backdrafting. We're actually really good at keeping the buildings from rotting. We just don't bother to teach architects this. So you're telling me the weatherization program is pretty damn good? Yeah. Well, why? Well, because they were pretty damn bad first. They were the worstest, the firstest, and now they're the bestest. Is new construction improving? Well, yeah. What happened is that because of all of the litigation, the legal lawsuits and the failures, the legal profession has become the most effective technology transfer medium in construction. You laugh, but it's, and in fact, I invented the term building commissioning. I said, we commission mechanical systems, why don't we commission buildings? And what happened is that insurance companies were refusing insurance unless the building enclosure was commissioned. Okay, Canada, it's an enclosure. America is an envelope. Building envelopes are American, enclosures are Canadian. Because I was first working with a guy by the name of Eric Burnett, a legendary guy. He says, young Joseph, Federal Express does envelopes, we do enclosures. I'm serious, that's, Canada, it's building enclosure, America, it's building envelope. I don't care, it's an environmental separator. So, what's the best way to build a building that doesn't burn? Non-combustible cladding, tempered glass. Why tempered glass? Boom! Airtight construction and filtration, right? Duh. Okay, hurricanes and floods. Dry, don't die. Flood is coming. Get the hell away from there! It's not like we don't know, right? And oh, it's climate change. Well, no, we're building more places that are flooding. There are more of us building stupid stuff in more stupid places. Can we build in stupid places and get away with it? Yes, but we have to build differently. We've learned a lot in Houston. Why? Because Houston got flooded on a regular basis, and they figured we should maybe build up. We should build out of stuff that we can wash, because flood water is very dirty. It's unhealthy. So wash, rinse, and dry. So we want to make the assemblies washable. You're kidding? No. Joe, did you come up with this? No. Claudette Reichel, LSU. She doesn't get the credit she deserves. So, buildings that were built in the 20s and 30s are much higher. Why? Because the people that built them said, gee, it floods here. We should build up. Anybody not get that? You go to New Orleans and you look at the older buildings, their floors are 5 and 6 feet off of the grade. The newer ones are just down there. Duh. Flood water is dirty, unhealthy. So part of this is once it drains, you have to clean it, decontaminate it. No salvage by order of Smith & Wesson. This is Texas. Well, okay, so you want to retain the brick veneer, you need to take the cladding off, the sheathing off from the inside, the interior insulation, gypsum board, hose it down. The reason they call Canadians hosers is because we learned how to do this first. And it's not Hoosiers, it's hosers. But anyway. You can then put a drainage mat on the inside of this and then paint everything with a paint that is washable that protects the wood, right? So we wrote this up. It was Claudette's idea. I cleaned up some of the building signs. LSU, the Houston home builders are really all over this. Because we're going to still build stupid places where it floods, right? Right. Well, we can make it work. Yeah. Oh my God, he's using spray polyurethane foam. We hate foam. Get over it. It doesn't suck water, and it's washable, but only the closed cell, right? Right. Well, what about extruded polystyrene? Yeah, some of you hate it even more, but it's washable, right? Right. How about something that really pisses everybody off? Some extruded polystyrene, some closed cell, and an intermescent coating so it doesn't burn, and it's washable. Woo! Well, this is a lot of carbon. Well, not over 100 years. How should we build it new? Put a drainage mat up. 1/2 an inch or less. Why? So it doesn't burn. Right? Whoa. Whoa. I just have to throw away the interior drywall on the first floor, right? Yeah. And wash it down. What should you not have on the first floor? Carpet. Duh. All kinds of ways of doing it. There's a retrofit. Yeah. What do they do in Florida? Well, they build up. They build the first floor out of blocks, put stucco on the outside. They paint the inside of the block. They got an air gap. And if it gets that wet, you just hose it down, right? Yes, Joe. Yes. Oh, can we do it with wood? Yeah, you can. Steel studs? Yeah, you can. Wow. Are we doing it now? Yeah. Again, Americans can count it upon to do the right thing after all of the alternatives have been exhausted. Well, don't freaking build there. Yeah, good luck with that. Oh, even better. Whoa. It's got to be high enough, right? Right. You can even dry it. Don't run the stucco into the ground. The stucco wicks water like crazy, right? Very capillary active. So you stop the stucco at the top of the slab and paint it. And run a polyethylene vapor barrier and capillary break under the concrete. And you put a seed in the concrete because there's going to be some water in the block wall. When the water runs down the holes in the blocks, we kick it to the outside. Wow. So guess what we're doing now? All of the slabs in Florida have a seat. It only took 30 years. But hey, you know, it takes time. Wow, this is a really robust wall that could, you know, handle the flood and a hurricane and an earthquake. Whoa. You have to do the Carole King thing, the earth moves under my feet. It's a earthquake resistant. Yeah, I know. Put it on the inside. Well, I don't like foam. Don't build where it floods. Hey, you know, you don't like it, don't use it. Don't build there. I don't like all the blocks. Can I do it with steel studs? Sure. But don't put any insulation in the steel studs. Why? Insulating a steel stud is a thermodynamic obscenity. 6-inch steel stud, put in an R19 bat, the effective thermal resistance is R5. Well, how do you know that? Well, because steel is 300 times more conductive than wood. You know how I know this? I've never seen wood wiring. or a wood frying pan. Well, wood frying pan once, but. This is neat. This doesn't burn, doesn't blow away, isn't an earthquake problem. It can be washed and cleaned. It's energy efficient. We know how to do this. We aren't doing a lot of it, but nobody, we don't have the technology. Yeah, we have the technology, just things have not become so intolerably painful and bad. Stupid has to hurt quickly, all right? All of these work. There are only two kinds of windows in the world, windows that leak and windows that will leak. The window detail on one side is what makes the structural engineer happy. You want that lip so that the wind doesn't blow in or suck out the window. Of course, when that piece of shit window, when that normal window leaks, it directs the water to the inside. So I came up with an alternative design. I came up with a tiered sill. So it still makes the structural engineer happy, but when that window leaks, the water is directed to the outside. There are only two kinds of windows in the world, windows that leak and windows that will leak. And windows are like people. As windows and people get old, we leak. You youngsters have no frickin' idea what's coming to you. This is on the coast of the Carolinas, right? Oh, it didn't blow away and, the waves crashed in and we saved energy and nothing rotted. Yeah, woo-hoo. We know how to do this. How many people have heard of the fortified program? Awesome. Sheathe the hell out of the outside of the building, right? Then protect the sheathing and design the thing to dry in both directions. Duh. And don't vent the roof. Vented roofs blow off. Yeah. This is in Pensacola. The Pensacola is called the Redneck Riviera. It's the Carolinas. Wow. Yeah. Okay, this is New Orleans. Brad Pitt got himself into some trouble, lower Ninth Ward. What happened was after the hurricane, put up a whole bunch of his money, and the mistake was they hired famous architects from New York and Los Angeles, because people who work in New York and Los Angeles certainly understand New Orleans. You're not getting the not getting the humor, and so I got involved because they got really rotting and whatever, and I want you to know that Brad Pitt didn't run. He invested another $20 million of his own money to fix it. It's too bad he and Angelina didn't get along, but he should be mayor of New Orleans. Guess what kind of an architect he'll never hire? Anybody from California or New York. Crawl space is very, very robust with floodwaters, but you got to make sure that you have a vapor barrier with continuous insulation on the underside. So it's got to be extruded polystyrene or foil-faced isocyanurate. It's got to be rated for fire, right? Right. And it would be nice to have the grade inside higher than the grade outside. If this is too complicated, let me know. It can't be this simple. It is. We're just not doing it. Yeah. Pier foundation up high. Yeah, woohoo. Rigid insulation underneath. Yeah, woo. Notice the insulation doesn't fill the floor cavity completely. There's an airspace on top. You know why? Makes the floor more comfortable. You fill it completely, the joists are going to be colder. Yeah. How do you know this, Joe? I turned 70 3 weeks ago. One day, you're going to know. Energy flow. So this is what made me famous after I got kicked out of Canada. This is Cleveland. And Gus Handegord and John Timmis, my mentors, you need to go to Cleveland and figure out why all of the paint is falling off their walls in Cleveland. And I said, well, you guys already know this. Why don't you tell me? You need to figure it out. Go. So I would drive 5.5 hours from my mother's basement in Toronto because I was already kicked out and single again in a rusted out Ford Tempo. And I met a guy, had a radio call-in show on Sunday mornings. House mender makes house calls. And his name was Jim LaRue. And he said, hey, I just got this guy from Canada. He wants to look at peeling paint. Any of you people got peeling paint problems, send us a card and the address and we'll go have a look. I got 500 cards. And I went and I saw 500 buildings. Yeah, that's me. And the correlation is that these older walls were retrofitted with insulation. It lowered their drying potential and the paint fell off. This was my master's degree. Insulation-induced paint and siding failures that led to my first peer-reviewed published paper. Yeah. Well, we shouldn't insulate. No, we just need to insulate differently. So the water was wicking in at the overlaps, always has been wicking in at the overlaps by capillarity, but the escaping energy allowed it to dry. So what was the solution? Oops, I thought I put the answer in. We would put wedges in. The wedges would open up the laps to provide a capillary break. In new construction, what do? You paint all 6 sides of the wood before you put it up, right? You also use bumpy nails. When you blind nail, you have a bumpy nail. Who told you about bumpy nails? If you go back 100 years, the old timers used bumpy nails because they were actually smarter than us. And they figured it out, but it's in old books that are found in things called libraries. But to get them, because they're old books, you have to ask a librarian, and that involves a social interaction, which is why youngsters have no freaking idea about any of this stuff. When we go to a bar later tonight, there are stories that I'm going to tell you, but I can't tell you right now. So we really screwed up Toronto badly. This is on the street that I once owned a house on. We insulated the attic, and the attic got cold. And what happened was frost would occur on the nails, the sheathing would get wet. When the attic wasn't insulated, we had the escaping heat. This dried everything out. Does that everybody understand what's going on here? So the only way to stop this from happening is we needed to keep the moisture that's inside the house from getting into the attic. So we air sealed. When we air sealed, what did that do to the furnace chimneys? Yeah. And what else did we do? Well, vapor barriers in the wrong place. Moisture flow is pretty straightforward. It goes from warm to cold. Why? Because. It's because of the second law of thermodynamics. Well, the science has been proven. You know, you're clearly an arts graduate. You don't prove science, you can only disprove science. Nobody's disproved this. If you were to actually disprove this, you'd get a first-class ticket to Scandinavia to get your Nobel Prize. So there are 2 things you got to remember. Moisture flow is from more to less and from warm to cold. You can do this experimentally. You can take something wet and touch something dry. The dry thing becomes wet. Who knew? Son of a bitch. Yeah. Yeah. So let's put vinyl wallpaper on the inside of an air-conditioned building. So the moisture is going to go from hot and humid outside. It's going to blow through the assembly and it's going to stop. And that's where you're going to get mold. This is a famous industrial hygienist, and he's been wanting me to never show this picture, and he wants to buy it back for me because he's now saying you have to wear a mask and protect yourself, right? And I'm saying, well, okay, if you give me the pictures you have of me doing stupid stuff, we're still negotiating. I'm looking for a quid pro Joe. Mold doesn't have an internal digestive system, so it exudes enzymes outside of its body, and these enzymes react with the plasticizers in the vinyl, and you get the pink and the yellow spots on the inside. We call that the Marriott measles, the Radisson rash, and the Hyatt hives. Because what are the moldiest buildings in the United States? Air-conditioned hotels with vinyl wallpaper. It gets worse. They have rooftop exhausts that pull air out of each of the units, so they're under a negative pressure. So the hotel sucks and has a condom on the wrong side. There's a reason they don't let me teach undergraduates, okay? Stucco failures. Exterior insulation finish systems. I predicted that this was going to be a problem. Why? Because I was so smart? No, I was stupid before everybody else. In other words, I did one of these and screwed up, and I said, oh man, that's dumb. So most hotels have drive it or stow, which are EIFS, but today's drive it and stow are water managed. They're drained. The original ones weren't. You just simply glue it against the wall of the sheathing. And when it leaked, you're screwed. So now you put a coating on the gypsum sheathing or the plywood or the OSB, and wait for it, you glue the expanded polystyrene up with vertical beads of adhesive. And when you smoosh, that's a technical term, the expanded polystyrene, you get a joint or a gap that's 1/8 of an inch. You get drainage. You're telling me all you need is 1/8 of an inch? Well, actually, all you need is a continuous 32nd of an inch. That was what the original gap for DuPont Tyvek drain wrap was. And I'll tell you where that number comes from. Well, it came from John Straub. His doctoral dissertation was on figuring out how much water drains based on what gap. And so his, but it was published, and so he didn't patent it, so that's why he works. And so when we put the stuff on without any water control layer, and the windows leaked, we had thousands and thousands of buildings rotted. And I predicted it. I was, ostracized. The owner wants the neighbors to know that that son of a bitch Eddie built it. There's Eddie. Okay, this is not Eddie, okay? He's a famous water guy. Steve Ruggiero with SGH, and he's one of the smartest guys in the world in this. And he's been wanting this picture back. Of course, we're I mean, it was just one duck. Okay, bad joke. Okay, so we've changed energy flow, and we have to compensate for it. Whenever we intervene and we dramatically reduce the energy exchange, we have to reduce the wetting potential to stay in hydric or moisture balance. What we're doing is we're reducing the energy flow, but we're not reducing the wetting. So buildings are staying wet longer, all right? It gets worse. Of course it gets worse. OSB. OSB is the spam of wood. Spam is the OSB of luncheon meats. Let's grind a piece of shit tree up into a gazillion pieces and smoosh them together. Yeah. You're not getting this, right? You see, youngsters don't get this, but we used to go to places 100 years ago called forests. We used to cut trees down and cut them into boards and build boats out of them and sail them around the world. Try doing that with a sheet of OSB. I view engineered wood as an insult to wood and engineers. And we're not building out of old wood. We're doing plantation wood and young wood. And we're using the cheaper species, right? So yeah, wood is good. It grows on trees and it saves carbon. Well, not if the son of a bitch only lasts 10 years. Now, can we make stupid wood work? Yes, but it's more difficult. And we're not doing it. I mean, really? This is better than plywood, right? No. But I can make it work. How? Have drainage on the outside. And don't have a vapor barrier on the inside. This is a little simulation I had some fun with. I had back at the days when the university still allowed me to teach youngsters, we had a lab. And so I have a piece of plywood and OSB exposed to the same conditions. And the OSB turns to crap and the plywood is just fine. Ooh, okay. Well, why? Well, as plywood gets, its moisture content increases, it becomes more vapor permeable. That's the brown, that hockey stick shape curve, because hockey is the sign of a just and civilized material. The OSB doesn't have that relationship, so you have to use it differently. Now, wouldn't it be neat if somebody invented an OSB that had the same curve as plywood? I know it's happening. I can't tell you much except with a hooker, a John Lee hooker, one bourbon, one scotch, and one beer. For you youngsters, that would be a Thorogood. All right, Vancouver, Canada became the rot center of North America because we had cold weather, lots of rain, and we had an incredible amount of OSB. We went from 2x4s to 2x6s to increase the thermal resistance, and they decided to put polyethylene air vapor barriers on the inside. Poly is a plastic condom. Don't do it. I'm tired of the passive house people running around with the polyethylene. I will hunt you down and talk sternly to you. So many buildings rotted so quickly that the joke was that when you applied for your building permit, they asked you what color the tarps were going to be when you had to redo the building in 5 years. And what do we do with that technology? We exported it to Cleveland. Yeah, and Pennsylvania. So Pennsylvania is now the stucco rot capital of North America, because there's an awful lot of stucco on 2x6 walls over OSB in Pennsylvania. Now, what happened? Well, in the old days, like a long time ago, we had things called building paper that was made out of impregnated felt. And we would call it 30-pound felt, because it would weigh 30 pounds per square for every 100 square feet. Now it's called number 30, because it only weighs about 15 pounds. Well, why is it a big deal? Well, when we put stucco up in the old days, over 30 pound, the 3 coats of stucco, the water would be absorbed by the felt paper, and it would expand and wrinkle and debond from the back of the stucco as it dried. And that allowed to have what happen? Drainage. Wow! So now what? Well, we put 2 layers up. The outer layer is a bond break to allow drainage to occur between it and the back layer, right? What is the worst material that you could use? Tyvek and Typar, any of the plastic wraps, because it sticks like shit to a baby's loose, yeah, right? DuPont had a product called stucco wrap. And I got into trouble because I said the only product it doesn't work with is stucco. So I woke up one morning with a roll of stucco wrap in my bed. But I love stucco wrap by putting tar paper over it, right?
There you go.
Woo! So the only thing that's worse than stucco is lumpy stucco, manufactured thin veneer, right? So they leak like crazy, and so you need drainage. And you can't do it with one layer of building paper. You can't do it with one layer of a house wrap. You got to have a drainage gap. The moment you have a drainage gap, whoa! Oops. So this is Pennsylvania. For whatever reason, Pennsylvania has become the stucco rot capital of North America. It's no longer Vancouver because we figured it out. Wow. Oh man, double danger. Thin manufactured stone and stucco, right? Let's put all of the crap we can think of in one building at one place at one time with the biggest risk. Yeah. Then let's insulate it up the yin-yang wazoo and put a polyethylene vapor barrier on the inside. Yay! And the only people that are happy are the fire people because it's too wet to burn. Whoa! I mean, look at this. Back in the old days, with plywood, water would hit the plywood and it would be pulled in to reduce the amount of wetting at the point of wetting by pulling it in and pulling it away, reducing its concentration. And then the plywood would increase its vapor transmission to both the inside and outside and would dry. Woo! Okay, you're not excited about this. You ought to be freaking excited about this. Well, what you could do is you could do the same thing with OSB. So I went to the OSB industry and I said, can you make me bumpy OSB? Get out of here. You know, we're not sure that the framers are going to be smart enough to put the bumpy side out. And so we taught sod layers, green side up. Surely to hell we'll be able to teach framers bumpy side up. So that didn't go anywhere. And I went to the people that made building papers and wraps. And I said, can you make me a bumpy building paper or wrap? And they did. But I wasn't smart enough to patent it, so I'm working today. All right, contaminants. Dilution is not the solution to indoor pollution. Source control, source control, source control. Now I spared no expense at providing a demonstration. Air is a fluid. This is a volume of clean air. This is an equal volume of dirty air. I'm going to show you the effect of one air change. Is this clean? Dilution is not the solution to indoor freaking pollution. Oh, we need to increase the ventilation rate or people are going to die. You're an idiot. Don't build your building out of stupid stuff. Don't do stupid stuff in the building. Yeah, I know. So don't build out of bad stuff. Don't fill your building with bad stuff. And don't do bad stuff in your building. Well, like what? Well, finishing your furniture in your living room. Yeah? Rebuilding your carburetor in your second bathroom bathtub. Right? All right. Dilution works for only people, but not for contaminants, because you can't do source control for people. Mrs. Kosnowski, you've got 6 kids, 5 of them have to move out. That ain't going to work. So you ventilate for people, not for the building. You ventilate for people, not for the building. Source control for the building. Source control for the people that are doing stupid stuff in the building. But people need clean air to breathe, right? Right. The problem is nobody can agree on what the ventilation rate per person should be. Because all of the original values were figured out for odor, not based on contaminants. As I point out, people are evaporatively cooled, unvented combustion appliances, some of them backdraft. All right, so build tight, ventilate right. How tight? What's right? This phrase comes from the Swedes that was translated by a guy by the name of Jim White of Canada Mortgage and Housing Corporation. We were arguing and figuring out what's the right tightness and what's the ventilation rate. And I want to tell you where those numbers come from, because everybody's quoting them and they have no freaking idea where they came from. And so the Swedish building code called for three air changes per hour at 50 pascals. I was in charge of a government program in Canada, the R2000 program, and I figured we played hockey twice as good as the Swedes. Our buildings are going to be twice as tight. So the Canadian number is 1.5 air changes per hour at 50 pascals. The Germans said, ha, we're better than you, and they came up with 0.47 or some stupid number based on a woofy simulation, which makes no sense. That there's no basis for that level of tightness, none at all. But hey, knock yourself out. Just, you want to do it, that's fine. So I tried to build 1,000 houses in Canada at 1.5 air changes at 50 pascals, and we couldn't get there reliably. But it was pretty easy. A couple of years go by, and I get money, and I'm now living in Chicago because I've been exported to Chicago. And we build 1,000 houses, we get rid of the big holes, and it was easy to get to 3 air changes per hour at 50 pascals. So the American building code was based on 1,000 houses that we built with Town and Country Homes, Pulte, and Centex, when there was still a Centex. And we actually, the NHB got behind it because the production builders, we went, well, Joe, what's a big hole? That's easy. Anything that you can put your hand through. We don't care about the small ones. No, I don't give a shit about the small ones. I want to get rid of the big ones. Well, okay, so that was for climate zones 4, 5, and higher. Well, why? Well, because those places had something called basements. Basements were invented to put mechanical systems in. That's where you put your ductwork, right? Well, in Texas, slab on grade, where does the ductwork go? In the attic. So a Texas attic is called a Texas basement. And those attics leak like crazy. So they go to a really high negative pressure. If you have a concrete basement, think of that as a cube. That's 5 sides of concrete. And concrete is a really good air barrier. Just ask Jimmy Hoffa. I was asked to define material, assembly, and enclosures. It was 1982. I didn't know, but Gus Hanegord, young Joseph, they've asked you to define an air barrier. I have a friend of mine, JC, Jean-Claude Perrault. He's in Edmonton. He's with PCL Construction. He's building apartment buildings using drywall as an air barrier. Go measure the leakage of 10 sheets of drywall. That'll define an air barrier. Well, I could only find 8 sheets of drywall. So the 0.02 is based on a young punk kid, me, measuring 8 sheets of drywall in 1982. 20 years go by and the Army Corps of Engineers and GSA is saying, we want a value for assemblies and enclosures. I simply took 0.02, multiplied it by 10, then multiplied that by 10, and that became the code. So you're telling me you pulled it out of your ass? It's a cute ass. And here's what I said. I said, we should probably test this. We don't have time. Give us your best judgment. Well, that was the best judgment. And it turned out to be, pretty good. But you shouldn't do stuff like that. It took 5 years and several millions of dollars of other experts to figure this out. To say, well, that was actually pretty darn good. Well, how'd you know to do orders of magnitude? Well, I was the last engineering class in Canada that was not allowed to use a programmable calculator. We had to use a slide rule. And the slide rule, you never knew where the decimal point was. So you had to do a calculation with a pencil to figure out where the decimal point goes. And there was a cigarette back in those days called Lucky Strike. Remember Lucky Strike? It was a white package with a red dot. And you had to be able to calculate the order of magnitude on the white part of the Lucky Strike. So we were called Lucky Strike engineers. We had a white shirt, short sleeve, of course, collar, pocket protector, and Lucky Strike. I never smoked, but I needed the Lucky Strike to be able to figure out the order of magnitude. So that's why I figured, well, shit, if it worked, we changed the entire code in the third world nation to the north of the United States, we could probably, get close. And it turned out that it actually worked out. But we shouldn't do stuff this way. Okay, I'm thrilled that I was the guy, but I'm embarrassed to say that's not the way we should change things. We should measure things, push them to failure, and then put in the safety factor. We don't have time, Joe, guess. Well, I'm proud of the guess, but I then spent, almost 10 years with a bunch of other consultants to actually figure out how close we were. But you shouldn't do it this way. You shouldn't do it this way. Getting rid of big holes, 3 air changes per hour. Getting rid of small holes, 1.5. And getting German, 0.6. The 1.5, I already told you, I simply divided the Swedish 3 by 2. The 0.6 was... Ask Hardwick Kunzel of the Fraunhofer over a beer. And he's one of the only 2 Germans that has a wicked sense of humor that I know. That's crazy. Okay, so when I was first asked to do air leakage testing, I was asked to measure 100 houses in 1982, and I was to pressurize them to 75 pascals. Well, in January of 1982, when I got the money to do this, it was freaking cold in Toronto. When we pressurized, we froze the pipes. So I turned the fan around and depressurized. My fan wasn't big enough to get to 75, I got to 50. So the original requirement was to pressurize to 75 pascals. We depressurized to 50 because it was cold and my equipment was too small. You don't understand how, well, there's a reason, it's 50 pascals, under a negative pressure. And I'm like, we pressurize ducts, we pressurize plumbing, why do we depressurize houses? Because it was fucking cold and my equipment was small. So, 5 years go by and I'm now got my master's and I'm in Ottawa with Professor Handegord and the National Research Council of Canada, Division of Building Research. And I said, Gus, I've always been meaning to ask you, where did the 75 pascals come from? Come with me, young Joseph. And he grabs my elbow and we go to the corner office of Building M30, the head of the entire Division of Building Research. George Tamura of Tamura and Shaw. George, young Joseph wants to know where the 75 pascals comes from. And Professor looks around and says, I didn't have a fan big enough to get to 100 pascals. So I tried to get the code changed with equipment today, and I said, well, we should be pressurizing to 100 pascals because it's more accurate. No, there's a reason we're at 50, and I'm like, it was me. My equipment was too small, and it sucked. Yeah, this is actually true. And part of this is we're supposedly more knowledgeable and more experienced today, but we're still stuck with some of the stupid ways of looking at things simply because at the time we had no other way of doing it, right? And, it's hard to improve because, okay, here's the deal. We never actually change anybody's mind. We have to outlive them. So I'm famous for taking people out for dinner, buying them steaks and alcohol, and they think I like them. No, I want to win the argument. Get them out of the gene pool and I'm healthy? Yeah. Okay, that's a joke. Okay, come on. So best, as tight as possible with balanced ventilation, energy recovery, distribution and mixing, spot exhaust, filtration, and material selection. Right? I mean, come on. We know how to do this. What's the worst? Leaky with nothing, spot ventilation, exhaust ventilation with no distribution and no mixing. That's what we're doing right now. And that's unacceptable. Now, new motto, build tight, over-ventilate right. Let me explain what I mean by that. The folks in the indoor air quality business are so concerned about contaminants, they want to double and triple the ventilation rates to deal with them, right? We want more, we want bigger numbers. And I'm saying, you don't get it. It doesn't work very well. And guess what? What does that do to the part load humidity and latent problem? You actually create mold. Okay, another reason I became famous is that air conditioners are dehumidifiers, but they only dehumidify when they're running. What have we done to the runtime of the air conditioner? So let's increase the air change in an efficient house with really efficient air conditioning, and now you need to buy a dehumidifier. So remember Mrs. Robinson, the movie where the future was plastics? The future is dehumidifiers. Now you go up north to Canada, the high ventilation rates end up drying the house out too much, so you need a humidifier. And I got into trouble because I said that humidifiers were ISIS bioweapons. Yeah. Because they evaporate bad shit that even the CDC says you have to use, or sorry, the Mayo Clinic says you have to use distilled water. And I see that all the time. I always see everybody using distilled water with their humidifier, right? Well, the CDC said that, the humidity helps fight COVID. Well, that's because COVID was an airborne transmitted disease, right? With particles. When you increase the humidity, water molecules are tiny magnets, H2O. So the water molecules stick to the particles and make them heavier so they plate out. So humidification reduced the airborne transmission. The trouble is the humidification rotted the houses and caused mold. Yeah. Okay, are you ready? Don't do stupid things. Don't kill people. People die from carbon monoxide poisoning. Carbon monoxide. And mold is dangerous. And the way you handle mold is you handle the moisture. The problem is it's getting more difficult to handle the moisture because we have less energy available. So we can't rely on drying, we have to rely on the prevention of wetting. And we're not doing it. So my challenge to all of you is, don't do stupid things. Let's be ultra energy efficient, but let's handle the moisture by source control, dehumidification, and up north, if you ever visit me, humidification with distilled water. With that, thank you for inviting me.
you, everybody.